Hello and welcome to day 2 of 11.2, simplifying radical expressions. Here are the solutions for day 1. Today I'm going to show you guys a couple new things such as rationalizing the denominator for starters, and then we're going to add and subtract. So yesterday I talked about this. If you have a square root in the denominator, you need to do something about that. And if it's in the numerator, that's okay, and that will happen. In fact, it'll happen a lot. But if it's in the denominator, it's not mathematically acceptable. So what we're going to do is you're going to take whatever square root in whatever square root is in the bottom and multiply that number on the top and the bottom as a fraction. The reason why you can do this is because you're just multiplying the number by 1. Root 7 divided by root 7 is 1, so you're not really changing the number itself, you're just changing how it looks. My recommendation is if this number simplifies, first simplify it, and then do this. So we have 5 root 7, and then what happens is we have root 7 times root 7, which is root 49, and then the square root of 49 is 7, and that would be the simplified form there. All right, here I have a variable, so I'm going to multiply by root 3b over root 3b. And so that'd be root 6b on the top, and then that'd be root 9b squared on the bottom. So we have root 6b over 3b. And there we go. One thing that you can't do is you cannot reduce the 6 and the 3 and the b and the b because the 6b is in the square root. So you got to treat that separately. If you had something like 4 root x over 8 root 5, something like that, you could reduce the 4 and the 8 and get 1 root x over 2 root 5, and then simplify from there, multiply by root 5 over root 5, things like that. Numbers outside of the square root you can simplify, numbers inside the square root you can simplify, but you can't mix them up. Okay, and then we're going to add and subtract radicals. This is similar to combining like terms. If I had 4x plus y minus 9x, I could put the 4x and the negative 9x together to get negative 5x. And this is no different. So I have 4 root 10. What that really means is I have root 10 plus root 10 plus root 10 plus root 10, plus I have a root 13. And then I have a negative root 10, negative root 10, and I have 9 of those. Okay, so that's really what 4 root 10 is. It's really what negative 9 root 10 is. But we're not going to write those out every time, but that's what those represent. So I have 4 root 10, and I'm going to take away 9 root 10, so there's going to be negative 5 root 10s. And then I have a root 13 there. And you're just going to leave those separately because they're not like terms. 5 root 3 plus root 48. Now you think like, oh, they're not the same, but root 48, you always want to simplify first before you do anything. So 16 times 3 is 48, so this is really 4 root 3. So I have 5 root 3 plus 4 root 3, together that is 9 root 3s. And then I got one more slide here. I was meant to crop this. 5 times root 5, 4 minus 1. This is multiplying. So you're just going to multiply like you normally would. This is the distributive property. I think it's supposed to be root. No, root 20. Okay, so we have root 5 times 4. And then I have root 5 times 20. And I'm subtracting them. So this would be 4 root 5 minus root 100. So 4 root 5, and then root 100 simplifies to 10. And then the other one, root 7 root 2. And this is like almost like a binomial times a binomial. So this is what it's going to go with here. It's almost like a binomial times a binomial. I recommend using the box here. Root 7 2. And then root 7 minus 3 root 2. And so root 7 times root 7 is root 49, which is 7. Root 7 times root 2, which is root 14. Root 14 does not simplify. Root 7 times negative 3 root 2 is negative 3 root 14. And then negative 3 root 2 times root 2 is negative 3 root 4. And then root 4 is 2 times negative 3 is negative 6. So I have 7 plus root 14 minus 3 root 14 minus 6. And some of the times they're going to simplify some things here. For example, the 7 and the 6 make 1. And then the root 14 and the negative 3 root 14 make negative 2 root 14. And that'd be your simplified answer there. So there are tons and tons of these types of problems. I'm going to focus on, let's just go, I like number 6 here. Let's focus on this one here. Tons and tons of these types of problems. So we're going to be practicing on this a lot. 2 root 7 minus 3, I'm going to break this up into 9 and 7. Okay, so I have 3 times 3 times root 7 here. So this is 2 root 7 plus 9 root 7, which is 11 root 7. There you go. All right, so make sure you check all of your answers to these problems because they're all slightly different as you're probably noticing, and it's very, very important that you can do all these. So if you have any questions, please see me, and I'd be happy to help you. Thank you guys for tuning in to day 2.